Good morning. This is Kapan Reddy, and this is the first day of Advent of Code. I have already done it in bed on my Android tablet about 2 o'clock in the morning. I set an alarm to try to wake up at midnight and missed it. Um, in any case, I'm recreating it here where I can record it more nicely. So the first thing I need to do is start up an Emacs. I already have several. So I'm doing this on my second account. I have a Google account that I do my main ones on, and a GitHub account that I use for a second one. So we're going to say create a file 202401.el, and we're going to put in it the template contents for Advent of Code 1. And somehow I didn't. Oh, I think I loaded the wrong version of Emacs. That didn't load my init file. So I'm re-executing the. Oh, that's because I called it the wrong thing. I misdiagnosed the error. That's what you get for leaping to conclusions. So here I am. This is my template. We have to go look at the problem. And as I've said, I've already done it. This is the sample input. It's a set of two lists. You have to find out the deltas between them, um, going from smallest to largest in each list and add those up. So this is going to be our little sample. And we define it. We need to define both of these. Require CL says bring in a common list compatibility package. I use the loop macro extensively. That comes from there. I also use setf and friends. And the debug on quit means that I can interrupt the computation by typing Control G and go into the debugger and see what's going on and continue onward. Normally Control G will quit out of something, but in any case. So um, we have this list of numbers, and then I also have to get my input, which is a much larger list. Control A, copy. Ink. That was not right. I thought I said copy. Puzzle input. Control A. Control C. Control Y. That was better. Don't know what I did wrong the last time. And now I've defined that variable too. So down here we have the two invocations of the code that I'm about to write, one on the sample and one on the real data. So the first thing we need to do is we need to get the numbers out of the lists. And as I said, I use loop macro. I'm going to say loop with lists equals, and I'm going to do that by basically reading all the numbers from the string. Input string is just the string of text, the two lines of, the lines with columns of numbers. I don't know why that got highlighted. I don't know why I'm down here either. Something weird happened either on my keyboard or my mouse. Anyway, loop for yeah n is the number and next is the next place in the string. Okay, so we need a starting point with start equals 0. That's our initial index. And we're going to call read from string In emacs Lisp, it returns a cons of the thing read and the next position in the string to continue reading from. In common Lisp, it actually returns two values. So you would have to, say multiple value list or something to get it into a destructured loop variable. So this is a function that won't run in common Lisp. Often they will. Read from string input string. If we look down at the bottom, we'll see that it takes an optional start. Now, one of the things is at the very end of the list, we'll get an error from this. So I'm going to wrap this in ignore errors, which means that if we get an error, we automatically, basically handle the error to get nil. I'm going to move this to the next line. Then I'm going to say while n, because if we did get the error, we would have gotten back nil as the cons, and of course then n would be the car of that nil cons, which is also nil, which means that we would stop the loop. So we have to do two things. We also need a way to tell which list it goes to. For I from 0, if odd pi collect n into second, else collect n into first. So we're basically taking the ends that we're reading, which ping pong back and forth from the left column to the right column, and putting them into two separate lists. And then in the finally clause, we can say return. And I know I'm going to need these to be sorted because we're comparing them size. So I'm just going to sort them here before I return them. So I'm going to be a list of sort of first, and I'm using less than as the comparison function, and sort of second, and I'm also using less than as the comparison function. So that gets us our two lists, and we could destructure them as left and right equal lists, just to remind ourselves what they are. So what we need to do is for L in left, for R in right, sum, which means return from the entire surrounding, loop, the result you get by continually adding, the expression that I'm about to type each time through the loop, sum minus LR, except that we don't know which one's going to be bigger, so we'll say abs of that. Absolute. So control meta E to go to the end, control X, control E to evaluate it. You can type them much faster than I can describe them. Highlight this expression, control the end, control U metacolon, and yank that expression back in. The control U metacolon says evaluated and insert the answer there. And we are looping or something. So that's control G. Look at that. We forgot a step. We forgot to update start. Now, again, I didn't have to control N down. That's force of habit. Control U metacolon. And in fact, it says 11. Is that the right answer? For the sample? Indeed, it is. So now we can do it on the whole list. Control meta add is this, oops, except that somehow something moved again. I think my keyboard is being flaky. Yes, I just left clicked and it killed the whole. Those mouse clicks are being hallucinated. I am not clicking them. I'm going to unplug the mouse and replug it in. It's going into a hub, so the hub itself may be the source of the problem. I'm going to undo. It's still doing extraneous mouse clicks. Okay, I may have to get a different mouse. Um, so, question is, yeah, because I killed stuff, other stuff was on there than what I wanted, so I'll get the, again, I did not click this. Control U, colon, Control Y. This is on the real input, so that's our answer. I'm gonna save this file, go back here and test the answer. It is correct. So, um, for part 2, it says that the results we got confirmed that there's something wrong. So this time we have to calculate what they call a similarity score by adding up the left list elements multiplied by how many times that number in the left list appears in the right list. So uh, similar trick to what we've done in the past. We're just going to add an optional part 2 argument. We're going to basically make the part 2 function just call the part 1 function with that argument. Set to t. We have to actually redefine this guy, and then define this guy. We can make sure that I haven't, well, all I did was add the optional part 2, so it's not going to affect the things. But what we want to do for part 2 is instead of summing this, so if part 2, we want to sum something else, we sum what we're doing. I always use debug as my placeholder because if I were to be interrupted and walk away and come back, this is a valid function, and if I tried to execute it, I would just go into the debugger and it would tickle my memory. Oh yeah, I haven't written it yet. You can also supply a string, so sometimes I will do this, but in any case, we're just going to write it. Killing a whole expression at a time and moving by whole expressions is one of the main reasons to use emacs for doing this sort of elisp programming. Uh, it also works in other modes, but not as well because other modes have more complicated syntax. So uh, uh, the language mode for C, for example, you can't say kill an expression and actually believe that it's going to kill the expression. Because it might not know the exact syntax for the expression. That's the beauty of having the very simple syntax for Lisp. Emacs can be completely sure that it's got the right expression. So what we need to sum is times left, times left, that's the left number, the number of times the left number appears in the right list. Loop for R for n in right count equal n L. So what we're doing there is we're saying go through the list of numbers in the right list, call each one successively n, and when the equal n1 equal nl is true, that means we're got the same value as the value we're currently looking at it in the left list, add 1 to the sum that's going to be collected by loop. So indeed, that should work. So let's first make sure I haven't worked part 1. Control X, Control E. Yep, it's still 11. Control X, Control E. Yes, it's still the right answer. Whoops, I always forget. So some puzzles have a separate sample for part 2, but this one doesn't. My template allows me to have it. So we just go back here. Ah, look at that. Oh, I must not have recompiled with the optional part 2. No, I did. Wrong number of. Oh, I called it part 2, not part 1. Okay, third time's the charm. Uh, so that says 31. What does the problem say? 31, okay. And now, that says that largest number. Let's see. And indeed, that's the answer. So, day 1 of 2024. Um, thanks for your attention.